Reinforcement learning, the fascinating field that allows machines to learn through trial and error, simulating the way humans and animals learn and make decisions. In this paradigm, agents interact with their environments, receiving feedback in the form of rewards or punishments based on their actions. Through a continuous process of exploration and exploitation, they aim to maximize their cumulative rewards and improve their decision-making abilities. Markov decision processes, MDPs, form the mathematical framework for modeling the interactions between agents and environments in reinforcement learning. By defining states, actions, transition probabilities, and rewards, MDPs provide a structured way to represent complex decision-making scenarios. Reinforcement learning algorithms leverage these MDPs, along with reward functions, to guide the learning process and enable agents to learn optimal policies. Reinforcement learning finds applications in various domains, including robotics, where robots learn to perform tasks and interact with their surroundings. From autonomous vehicles navigating complex road networks to robotic arms grasping objects with precision, reinforcement learning empowers machines to adapt and improve their performance through experience. In energy management, reinforcement learning algorithms optimize energy usage, scheduling, and load balancing, leading to more efficient and sustainable energy systems. By learning from historical data and continuously adjusting their policies, these algorithms enable smarter energy consumption and reduce environmental impact. Beyond robotics and energy management, reinforcement learning has been applied to areas such as finance, healthcare, and game playing. It has shown promising results in portfolio management, clinical decision support, and strategic game playing, demonstrating its versatility and potential for solving complex real-world problems. Stay tuned for our upcoming videos, where we will explore advanced reinforcement learning algorithms, cutting-edge techniques, and real-world applications. We will dive deeper into topics such as policy gradients, actor-critic methods, and meta-learning, providing you with a comprehensive understanding of this exciting field. Don't miss out on these valuable AI insights. Stay tuned for more exciting content on reinforcement learning. Thank you for watching.